Hello everyone. In this video, we will get introduced to new concept called proportion. Let's take one example. I have a picture of a monument. Let's consider Taj Mahal. So when I get a picture of Taj Mahal, will it be in the same size as actual Taj Mahal? No. So if the actual Taj Mahal's length is, let's say, 400 meters, what would be the length of Taj Mahal here? It has to fit in the photograph, in the picture. So let's say this is only 40 centimeter. If the actual Taj Mahal's height is 300 meters, then what should be the height of Taj Mahal in the picture? Now if I put it, let's say 20 centimeters, the Taj Mahal will not look like the actual Taj Mahal. It will look distorted. So what I need to do is I need to keep the same ratio. So ratio of length here, whatever is the ratio of length, I need to keep the same ratio for the height as well. And only when I keep the same ratio in the height, the picture will look like the original one. And in such cases, we call the length of the Taj Mahal to length of Taj Mahal in picture is in proportion with height of Taj Mahal in actual to the height of Taj Mahal in picture. So these two ratios, we say they are in proportion. When the ratios are equal, we call the ratios are in proportion. So when we buy items, so if I buy 6 apples for 120 rupees and I want to know how many apples I will get in 180 rupees, then I need to use the proportion, because the ratio of the cost of the apples is going to be equal to ratio of the number of apples. Though the units are different, here it is rupees, here it is numbers, still the ratio is unitless. So when we see the ratio of the cost, it's going to be a number, unitless number, and that ratio should be same as ratio for apples as well. And that's how we make use of proportion in day-to-day life. The ratio is shown like this. So let's say 120 rupees, we said 120 is to 180. So whatever is the ratio between them, 120 is to 180. Then we show two sets of columns and then we write 6 is to 9. So that means this rupees 120, rupees 180, 6 apples, 9 apples. Now they are in the same ratio. So this quantity, the ratio of money is in proportion to ratio of apples. And that's where we say 120 is to. We know this. We call, when we show ratio, we say is to. And this, which shows the proportion, we call as. So we'll call this 120 is to 180 as 6 is to 9. 120 is to 180 as 6 is to 9. And the ratios are in proportion, and proportion means ratios are equal. That means 120 upon 180 ratio shown in fraction format is equal to 6 upon 9. And if we see here, if I remove the common factor between 120 and 180, the common factor, let's say 20, 26 are 180, 29s are. We still have a common factor, but I just wanted to show that they are equal. So 6 upon 9 is 6 upon 9. So we saw what is proportion, we saw how it is represented, we saw how it is pronounced. Let's now see what are the different terms here called. So I had 120 is to 180 as 6 is to 9. And that can be shown in fraction format as 120 upon 180 is equal to 6 upon 9. So now if you see, these terms both are in numerator, these both are in denominator. So this first term and this first term, or this second term and this second term, these are called respective terms. The terms which are inside, there are 4 terms, and out of that these 2 terms are in the middle, 180 and 6. They are kind of terms which are in the middle, and these are outer, these are inner terms. 120 and 9 are outer. So these 180 and 6 which are on the inside, they are called middle terms. Whereas this 120 and 9 which are on the outside are called extreme terms. So we have respective terms. Respective terms are from the first ratio, first term, from the second ratio, first term. So 120 and 6. Same way, from the first ratio, second term, from the second ratio, second term, 180 and 9. These are called respective terms. The terms which are on the inside, out of the 4 terms, term 2 and 3, they are inside. They are flanked by 120 and 9. So these are inside terms, they are called middle terms. And the outside terms, 120 and 9, they are called extreme terms. Now we see, why do we need proportion? Let's take one example. I have some chocolates and you have some toys, small toys. Let's say I have 24 chocolates and you have 6 toys. Now I give you 4 chocolates and I say, now give me 4 toys. Because I gave you 4 chocolates, give me 4 toys. You say, no, that's not correct. You say that I will not give you 4 toys, I will give you just 1 toy. How is that correct? So, reason for that is, if you see here, out of 24, I have given 4 chocolates. So, I am giving 1/6 of the chocolate. 1/6 of the chocolates, 1/6 of total 24, which is equal to 4. So I'm giving you 1/6 of chocolates. And that's why you say, you will also give me 1/6 of toys. And that is going to be 1. And what you're trying to do is, you are trying to do distribution using proportion. So sometimes like when you buy some things, you divide the profit and loss. In such cases, proportion is important than just the absolute value which you are giving away or you are taking. And in such cases, we ensure that we divide the things in the same ratio, and hence we make use of proportion. I am sure you have liked the video. Hit the like button and leave your views in the comment section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the QTube app at the link provided in the video description. Till we meet again, goodbye.